All right, today gonna be a pretty quick and easy day. I'm gonna do some angle pair relationships, dealing with parallel lines and transversals. That's pretty much it. So I think this should take no more than 5 minutes or so. All right, for this to make a lot of sense, I like to start off with just one line. And if I have a line and I just draw a transversal to cut right through it, doesn't matter how I lean it, I'm just gonna intersect. What I've created is 4 angles. 1, 2, 3, 4 different angles. I don't know what I realized when I first was introduced to this, it kind of made a lot of sense to me. So I'm just going to make up some measurements real quick. I'm going to say this one right here is like, I'm going to say that's 35 degrees. Quite naturally, this right here would be the same thing because they're pretty much reflecting each other, right? So that's also 35 degrees. In geometry, we call that relationship vertical angles. The ones that are across from each other like that, they're vertical angles. Now over here, because this sits on top of a line, if this is 35 degrees, to swing it all the way back around to this side, remember, when you sit those 2 angles on top of a line, the total should always hit 180, all right? So if that's the case, then that makes this part of it 145 degrees. So that's also 145 degrees right there. And if that's 145 degrees, so is that one. All right, so vertical angles, they are equivalent to each other. They're congruent. That's another word we use. And those are congruent to each other because they are vertical angles. Now, the ones that sit right next to each other that create that line or create that line, those are what we call linear pairs, all right? So we have vertical angles that are across, then we have linear pairs that create the line. All right, so when we start talking about angle pair relationships, a lot of times that this idea is introduced isn't just intersecting these 2 lines. What we like to do is create a parallel line. And now we're talking about one transversal cutting through 2 parallel lines. So the way that I was able to get this one so quick is once you kind of understand what's going on here, that same process is repeated here. Because what's so different between this and this? There's nothing different from it. So like if I were to take all these and slide it down here, the numbers wouldn't move. This will still be 35 degrees. And so it is vertical angle. That'll still be 35 degrees. This will be 145, and that'll be 145. All right, so this is how problems like this start to get presented. It's more about, okay, we might give you a degree measurement, then we have something else in there where you have variables. So now we throw that unknown value in there. So what you have to do is, with a problem like this, you have to understand what the relationships are first. If you know they gave you 100 degrees, if you have 100 degrees right here to work with, all you have to really do is find out where else can that 100 degrees fit. It's not going to be there. You can look at that and tell they're not the same measurement. But if we use our vertical angle, we know that that is also 100, right? And if we use what we call alternate interior, I can cross it over to here. That's also 100 degrees. Once I have it set right here, that's where I can stop moving this number and start figuring out how do I get to this variable, right? So remember, these 2 sit on top of one line. That means if I add these up, my total is 180. So verbally, if I add them up, my total is 180. Mathematically, I can add them up, and that is 180. You get what I'm saying? So that's why it's very important to understand vocabulary. It's very important to understand how to talk through it, right? Because that's going to help you set up that problem. Remember, the whole point of geometry isn't necessarily you getting an answer. It's like, how do you reason through it to set up your own work? Because we're not going to set up that work for you most of the time. Most of the time, it's going to be up to you to put this together in mathematical form. So we go through our solution process. You know, I can subtract 100 on both sides. That leaves me with a 2x minus 80. Then I could divide 2 on both sides. That leaves me with an x is equal to 40. So x is equal to 40. So if I put a 40 right there, 2 times 40 is 80, and 80 plus 100 is 180. That's how you know it's correct. Because remember, linear pairs do total up to be 180 degrees. Here's another example. So these two lines, we're going to assume that these two lines are parallel and it's being cut by a transversal. Now look at that. Most people get confused here. They don't know where to start. I know where to start. You should know where to start, but let's talk about that real quick. Remember, if you pay attention to where this is placed, if this is sitting right here, right, there's another angle that's the same measure. That angle is the same measure, right? There's another angle that's the same measure. This angle is the same measure. Then there's another angle that's the same measure, that one. So all four of these angles that are marked up have the same number. So let's assume this is 50 degrees, right? If I say this is 50 degrees, so is this, so is this, so is this. If this is 50 degrees and that's 50 degrees, that means they're equal to each other. The key is I said something very important. I said they are equal to each other. So if you get away from focusing on what is x for the moment and focus on they are equal to each other, therein lies how you set up the problem. They are equal to each other. So I say 5x plus 23 is equal to 7x plus 13. That's what's going to get me to set up the problem. Once I know that, I can figure out what x is. All right, so I'll solve it. I'll subtract 5x on both sides. Then I'll subtract 13 on both sides. So x must be equal to 5. X must be equal to 5. Yeah, what you'll notice with a lot of these types of problems dealing with the angle pair relationships, a lot of times when we talk about like the easier to medium difficulty level, either you're going to be setting angles equal to each other or you'll be adding them up to total maybe a 180 a lot of times. Then they throw like maybe the harder ones in there where not only do they cut it by a transversal, they also throw another little line segment in there and they might break up one of the smaller angles. So like, I'm not going to do one of those examples yet, and I might save those for tomorrow. But I hope that gives you a basic foundation on how you should look at lines and transversals and how you can use your angle pair relationships to either set things up equal to each other or total them up to your 180.